Dear chemistry aspirants, right now I have the chemistry book unit 5 and states of matter will be discussed right now. And in this segment, introduction is here. In previous unit we have learnt about the properties related to single particle of matter such as atomic size, ionization, enthalpy, electronic changes, charge density, molecular shape and polarity, etc. Most of the observation characteristic of chemical system which are we are familiar represent bulk properties of matter, i.e. the properties associated with a collection of a charge number of atoms, ions and molecules. So here I would like to discuss the intermolecular forces. Intermolecular forces are the forces attraction and repulsion between interacting particles. So repulsion and interaction, atoms and molecules. The term does not include the electrostatic forces that exist when between the two oppositely charged ions and the forces that holds atom in of a molecule together, i.e. covalent bonds. So opposite charges will be needed, and atoms and molecules, and repulsion and interaction, two forces are here. Intermolecular forces will be dealt with the attachment of repulsive and interaction and charged ion between oppositely charged ion. Opposite, you can say the plus and minus. Attractive intermolecular forces are known as van der Waals forces. What is van der Waals forces? In honor of Dutch scientist Japanese van der Waals. Time was 1837 to 1923, who explained the deviation of real gases from the ideal behavior through these forces. Who explained? Van der Waals, Dutch scientist Johannes van der Waals, in 1837 to 1923 was the time. He will learn about this later in this unit. Van der Waals forces are vary considerably the magnitude and include dispersion forces or London forces. So which include dispersion forces, also known as the London forces, dipole forces and dipole induced dipole forces. A particularly strong type of dipole interaction is hydrogen bonding. So related to hydrogen bonding, only a few elements can participate in hydrogen bond formation, therefore it is treated as a separate category. Few elements, regarding separate category, we have already learnt about this interaction in unit 4 of this book, +2 level chemistry. At this point, it is important to note that attractive forces between an ion and a dipole are known as the ion dipole forces. These are not van der Waals forces. We will now learn about different types of van der Waals forces. So van der Waals forces are many in forms that we will discuss in again and again in the next segment, that is the dispersion forces or London forces is here. Dispersion forces or London forces, atoms and nonpolar molecules are electrically symmetrical and have no dipole moment because their electronic charge cloud is symmetrically distributed, but a dipole may develop momentarily even in such atoms and molecules. This can be understood as follows. Suppose we have two atoms A and B in the close vicinity of each other location. Figure 5.1a provide you the information. You will see here the picture and photograph what I am discussing. It may so happen the momentarily electronic charge distribution in one of the atoms, say A, becomes unsymmetrical, i.e. the charge cloud is more on one side than the other. Figure 5.1b and c. This results in the development of the instantaneous dipole on the atom A for a very short time. This instantaneous or transient dipole distort affects the electron density of the other atom B, which is close to it, and as a consequence of a dipole is induced in atom B. The temporary dipole of atom A and B attract each other. Similarly, temporary dipoles are induced in molecules also. This force of attraction was first proposed by the German physicist Fritz London. So why given the name London? The first given by the German physicist Fritz London, and so for this reason force of attraction between two temporary dipoles is known as the London force. Another name for this force as dispersion force. These forces are always attractive and interaction energy inversely proportional to the sixth power of the distance between two interacting particles, i.e. 1 by r6 r squares r to the power 6, where r is the distance between two particles. These forces are important only at short distances, approximate 500 pm, and their magnitude depends on their depends on the polarizability of the particle. So here you will see the distance is 500 pm and their magnitude depends on the polarizability. Polarizability is here and particle. In the next time we will discuss 5.1.2 dipole forces. So when you study the states of matter, and objective is here, after studying this unit you will be able to explain the existence of different states of matter in terms of balance between intermolecular forces and thermal energy of particles, explain the laws governing behavior of ideal gases. So here is the objective and introduction, and here is the content. We will meet in the next session with lot more. Till then, thank you. Thanks for watching the video. Thank you.